Now let me just switch gears in the last 2 minutes here, and I'll show you the kind of biomarkers I study. So those proteinopathies evolved in the brain, neurons, brain cells got sick, brain cells started to die. Brain cells normally make up these vast connections of networks all over the brain, and these networks are critical for controlling our behavior, our thoughts, our cognitive functions. But when the brain cells get injured and die, these circuits are going to be affected and they're going to become dysfunctional, and it's going to lead to altered behavior. And that's what happens at the earliest stages in Alzheimer's disease when people start to have memory deficits. It's because the memory circuits here are becoming affected. I happen to study eye movements as part of ANDRI. This just circumnavigation of the brain shows all the brain areas involved in controlling eye movements. This slide shows the insane set of circuits of all the brain areas connected to control eye movements and blinks and pupil responses. So I'm an expert in this network. And I just want to show you one biomarker that we have from the ANDRI participants by measuring the size of their pupil while they were watching TV, and we were changing the channels. So this is to represent time, and every one of these little blocks is when we showed the patient a different channel. And at this red line, we went from where the screen was relatively dark to where it was much lighter. So the extreme of this is when you're in a dark room and you walk outside in the sun, it's really bright. One of the first things that has to happen is your pupil constricts. And you compare that when you're in bright light and then go into darkness. One of the first things that has to happen is your pupil has to dilate. And so we set up these changes in luminance in our eye tracking experiment. And I just want to show you one example here where I'm plotting in time the change in pupil size. And this is from a group of 100 control subjects showing when they went through one of these transitions from dim to bright, the pupil constricted. And when they went through one of these transitions that went from bright to dim, the pupil dilated. And when we showed this same experiment to patients with Alzheimer's disease, yes, the pupil constricted on the bright clips and it dilated on the dim clips, but there was a dramatic difference in the pupil response compared to the control subjects. The green line here shows the responses we got from Parkinson's patients. They were more similar to the elderly control participants, but again, dramatically different from Alzheimer's, reflecting the difference in the proteinopathy in these two different diseases. And so I won't go on any further showing you any more of this pupil disease, but just showing you how we're measuring the pupils of the patients and how they're dramatically different. And that's being driven by these proteins attacking these circuits in the brain that control these behaviors. And so I think I'll stop at this time and take any questions if there are any.